Human reproduction rests on a single microscopic event. Once an egg bursts from the ovary, the clock starts on a strict biological deadline. It survives for less than 24 hours. Despite those stakes, the window is frequently missed. The error stems from trying to predict a complex biological process using static dates on a calendar. This chart compares a standard 28-day calendar model against actual fluctuating cycle lengths recorded in clinical settings. The popular assumption that ovulation always occurs on day 14 assumes perfect clockwork, yet healthy reproductive cycles often range anywhere from 24 to 32 days. Pinpointing the narrow window of opportunity requires moving past paper schedules and observing the body's internal communication network in real time. Relying on generic math rather than specific physiological signals is the primary reason the fertile window passes by unnoticed. The process begins deep within the brain. The hypothalamus signals the pituitary gland to initiate the cycle, releasing follicle-stimulating hormone and luteinizing hormone. These travel through the bloodstream down into the reproductive system. Once FSH reaches the ovary, it triggers the growth of several follicles, sacs containing immature eggs. Over several days, one of these follicles takes the lead, growing larger and achieving biological dominance. When mature, the brain releases a massive surge of LH. This chemical trigger causes the follicle to swell and rupture, releasing the egg. This rupture is the exact moment of ovulation. It is a physical event triggered by reaching a specific chemical threshold, not a scheduled date on a calendar. Once released, the mature egg survives in the fallopian tube for only 12 to 24 hours. Capturing a window that brief requires absolute precision. Even a one-day calculation error means the chance for fertilization is lost. However, the biological timeline is broader than the egg's lifespan because of how long sperm can survive in the reproductive tract. Under the right conditions, sperm can survive internally for up to 5 days, waiting for the egg to arrive. Combining the sperm's multi-day survival with the egg's 24-hour lifespan creates a total fertile window of 5 to 6 days. To maximize pregnancy chances, sperm must be present before the LH surge triggers the egg's release. Success depends on anticipating the rupture window rather than reacting once it has already passed. Detecting these internal shifts does not require laboratory equipment. As the hormonal cascade progresses, the body undergoes a series of specific, observable physical changes. One change occurs in the cervical mucus. As estrogen levels rise, this fluid becomes clear and stretchy, resembling raw egg whites, a texture that indicates the fertile window is opening. You can also measure the hormonal surge directly with at-home ovulation test kits. These strips detect the rising LH levels that signal the follicle will rupture within the next 24 to 36 hours. After the egg is released, the body begins producing progesterone, which slightly raises resting heat. By using a precise thermometer to track basal body temperature every morning, you can identify the thermal shift that occurs once the follicle has ruptured. This matrix categorizes the different tracking tools. Cervical mucus and LH kits act as predictors that the window is opening, while temperature tracking confirms that ovulation has successfully occurred. While at-home tracking provides significant insight, irregular cycles or prolonged difficulty often warrant consulting a professional to investigate factors that simple tests might miss. Understanding these physiological markers moves fertility away from calendar-based guessing and toward data-driven control of your own biology.